Cool. It's about 5 minutes after 11, so we'll go ahead and get started. Uh, Thanks for joining everybody for this scanner spotlight by Digitize Designs. I'm Patrick Paz. I'm the engineering manager here at Digitize. If you're not familiar with our company, we are a 3D scanning solutions provider. So we carry a variety of hardware and software solutions for 3D measurement problems. Anything from 3D asset creation, reverse engineering, inspection. So yeah. We got a few varieties of hardware. We carry Artec, Scantec, and FARO are the three big ones. Today we'll be focusing on Scantec. The scanner we're looking at today is the FARO Leap ST. That is this guy right here. Handheld blue laser metrology scanner in the FARO lineup. I've got a couple projects we'll work on with it today. First off, we'll start with a multi-piece inspection of this bell housing. We'll measure that a few times, kind of show you the how something like that might work. If you've got a whole batch of these, you wanted to set up an inspection station and measure these very accurately, very quickly. And then I've also got this larger part back here, this car door that will show a couple of the other modes of the Leap. Something really cool about it is it's got a lot of different scanning modes that are good for anything from really large stuff, medium-sized things very fast, and even super small, super high resolution, high detail. So it's a very versatile scanner. It's accurate to about 20 microns, so about 8/10,000ths of an inch if you're used to thinking in inches. There's got a volumetric accuracy for larger parts that you can greatly reduce, volumetric error you can greatly reduce by using this photogrammetry system that is built in. So these scale bars and the coded targets that you can see on this car door help us do that, and I'll go through that process once we get to that door. You got 5 different laser modes that we'll walk through once we start scanning. Without further ado, I'll jump into show you my screen and jump into this first project. So we'll be running the Leap inside of Polyworks with the FARO Leap Capture software plugin. So I've got my CAD model of this part loaded up. I've already defined some measurements, but we'll set up a couple more, and we'll scan this all inside of here, bring that scan data in, extract all those measurements, and create a report as if this was a part we were manufacturing. We wanted to do some quality inspection on it, and then report all that out. So here's all the measurements I have defined. Looks like a whole lot, but it's mostly all these hole positions, a few different planes to get some GD&T, some flatness on some planes and such. But setting up features is really easy. If you've got anything you want to measure, you just got to create the basically point Polyworks to what you want to measure. So if you wanted to get the thickness of something, there's a variety of ways to do that. If you needed a plane-to-plane distance, you got to create those 2 planes and just measure between them. You can even grab like virtual caliper measurements, for example, and say, I want to measure from here to here, and it's going to just grab a little virtual caliper and actually, grab a kind of like the way a micrometer works. It's got these circular anvil heads on the end. It's going to use those until retract to a certain distance, and then touch the CAD model to get your nominal measurement, and then touch the scan data to get your measured, and then compare those 2 values and give you the deviation between them. So anything you can think of, you could define in CAD or on a part, you can measure here. Setting up those measurements is really simple. So let's measure this one. Bring up the FARO software. Sorry, I got too many monitors. The little box is hiding from me. There we go. It's just asking me if I wanted to clear out my previous scan, and I do. So here's my Leap Capture software. So I've got all my scanning settings and everything ready to go. Resolution, if you want to control how closely the points it's capturing are to each other. Exposure, you can adjust that for scanning harder to scan surfaces. Things like dark and shiny and transparent are typically difficult to scan optically, but these blue laser scanners, this category of scanners, really good at handling those surface finishes. just going to start out. I've got a template set up for this turntable that's just got those targets ready to go on it. It's really easy to scan those if you don't already have that template. But what that allows me to do is set this clipping plane, can select some of those targets and say, I don't want to collect anything below that. I know I just want what's on top of the table and not the table itself. So we'll do that, and then scanner's ready to go. So you can see it's watching for those targets. You can see the green ones are the ones that it can see right at this moment. The white ones are ones it knows that are there. It's not using right this minute. It's using those targets to keep track of its position. And then it's also watching those lasers you see on the part and on the screen to keep track of or to measure the part. Everywhere one of those lasers hits, it's able to scatter points along it, and then it's going to collect those here in Leap Capture. So as I move around this part, it's going to fill in. It's kind of like painting with light. As soon as I can see that stuff fill in, I know I've captured it. Got a few different laser modes we can go through. So I've got single laser. This one's really great at getting into like deep crevices and holes a little bit deeper than you might be able to with the primary ultra fast mode. You've also got hyperfine, which I have disabled right now. I'll show you that one on the next go around. So as we measure everything that we need, or as soon as I see it all on the screen, I know I've got everything I need from this position. We're also going to flip this over and scan it from the other side, combine those two together. So we'll get a full 360-degree picture of this whole part, anything on it we might want to measure. This one's done. I've got some noise in space that's out in space there. That's kind of typical with laser scanners. It's really easy to handle. You just hit this disconnected data button. It'll highlight it, and then you can throw it away. We'll do another scan. I'll bring in that template again. We'll set up another clipping plane. Flip this part over. And then we'll repeat one more time. Let me turn on those other laser modes we were missing so I can show you those. Cool. So ultra fast is this one we've been in most of this time. It's two sets of laser lines. So one set of crosses fills in a very large area very quickly. We've also got hyperfine. So this is 7 parallel lasers that you do have to get a little bit closer with, but it's a little bit better suited for tougher surface finishes and scanning at higher resolutions. Single laser we already took a look at. Oh, sorry, that one's infrared. We'll get to that one when we get to the hood back there. Single laser, and then back to ultra fast. I'm going to fill in. I've got everything I need. Since I know I've got everything that I missed in that first scan, I can still go make sure I've got everything on the middle in the middle that overlaps with that first one. But the only thing that was critical here was anything I missed on that first go round. So as soon as we finish this inside, we can end this one. Now I've got these two sets of data that are not aligned, but got a couple of different ways I can align them together. I'll show you target registration on this one, and we might switch it up for the next. But since I've got a few targets on the sides of the part that were seen in both scans, I can do a target registration. That will allow me to align this scan with this one just using the targets on board. So the only input I have to give it is zoom in onto the second scan and highlight the targets on the part. So just those ones there, missing the ones on the table. And then once I click this apply button, you should see these two snap together. Those will snap together, gives me some error readouts, and I can combine them together into one data set. Still a point cloud at this point. If we zoom in, you can see the individual squares it uses to display those points because it's collecting their position as well as the direction they're facing. That's why it renders them as squares. We can connect the dots between all those squares by meshing. Actually make this a true surface model. Actually also makes the data a little bit more optimized for bringing it over into Polyworks. You can describe the same surface with way fewer triangles than you can points and less data. to describe the same geometry. There's our mesh. Got that noise in the middle. I can just lasso it and delete that if I'd like. So now we can send to Polyworks. It's going to pop up here, say, does that look right? Does it look like what you're expecting? If I think it is, I can continue. And all the rest of those measurements I defined are all completed. So everything's updated with that new piece information. So it made all these features that we were looking at here. It made me this color map to show me how well an overall picture of how the part matches up to the CAD model, how that scan matches up. I can adjust this dynamically if I wanted to see more extreme color ranges. So right now we're looking at about half a millimeter high, half a millimeter low to those extreme colors. We can even throw some comparison points on here to see exactly what this is calling out at any specific spot. Notice this little color map or those little comparison point flags or color match the color map too. I just thought that was neat. So what else got, the other thing that got upgraded in the background when we created this new scan was this report. So this was automatically generated as we defined these features, or as we made the 3D view look like what we wanted each one of these pages to look like. There's just this button here called Create Control View, which is Polyworks for make me a page of the report that looks like whatever I'm looking at right now. And so that made me this page here. We did that a couple more times. So we've got looks like 6-page report right now, cover page, one for the heat map, one for this set of holes. And so an image of exactly what's in there, what's displaying, all the characteristics of each of those features that you asked it for, and a table of everything. So this is just the default way to create a PDF report. If you wanted this stuff in like Excel format or a CSV or something like that, you can also export that too. But report editor is super robust and really easy to edit stuff in. If you wanted to like get rid of some of these columns, all I got to do is open up this little box. I can throw columns away that I don't want. We can edit, get rid of some of these headers up here if we want. If you want to move stuff around, it's really fast. Say I want to switch these pages, just drag and drop. I wanted to put this color map up on the front page with this guy. We can just resize him out of the way and grab this guy, drop him on the front page and resize him. Really easy to make a really custom report. Put him back where he was. There we go. Cool. So that's one piece. Say we've got more of these. I only have the one, but we'll just put it back where it was and pretend it's a second one. I've got some marks on the table. I'm going to try to line it up very similarly to the way I did the first time. I don't have to be really precise. I'm just eyeballing some Sharpie marks, and that'll help make this next measurement a little bit more, well, just as automatic as the first one was. So we'll do all this again. New piece, delete my first go around, bring in this template. And this time I'll talk a little less and let you watch me do this one. Side one done. Side two. Combine the two, mesh them, and then we'll be back in Polyworks in just a moment. So there's a second part done. Again, all those same measurements, and new report. It's keeping a log. I've done a few pieces before we did this, so I've got now up to 7 in here, all stored within this project. I can go back and look at any of the measurements of any of those. So let's do that one last time, and this time I'll show you this this menu here. So if I've kind of been breezing through it, but there's a couple of things I can do here. Say there's some stuff I want to record about this that isn't just measurements. If I want to record that this was me that did this, the temperature in the room, it's a serial number of the part, any kind of like metadata you might want to associate with the this particular piece, you can punch all that in here before you go, and Polyworks keeps track of all that for you. So again, we'll do this one last time. This time I left out the background plane, so I'll show you how it's really quick to handle cleaning that up. If you forget that step, or you're in a scanning on a fixture that doesn't make sense to do a background plane with or something, it's still really easy to handle. So I could go create that plane the same way I did the first time, and it would just delete everything. I can also just change my camera view here. So we're looking like down the barrel of the table, if you will, and select all that data with a lasso and just get rid of it that way. So that first side done, bring in that template again, flip this over a final time. Actually, it does not matter which way I do it. Background plane or clipping plane, excuse me. Scanning with this ultra fast mode is a little more like there's a solid area that's just filling in than if you're used to scanning with like a single laser line. So you can fill in really large areas pretty quickly. I don't know if you notice, I'm just doing kind of finding one good position that I'm making full use of that patch of lasers and kind of just doing a rotation of my turntable here and filling in things really quickly. Get rid of those disconnected components. Do one last registration. all those measurements for a third time. So now that I've got so many pieces in here, there's a few cool things about that. One, something really neat about scanning versus like probing is, for example, is that everywhere that I've scanned, I have measurements on, even though I might not be using all of that scan data in some of these measurements. There might be an area of this that if I didn't have that data, it wouldn't affect the any of these measurements that I have extracted. That's still there for me to refer back to later. If I wanted to add a feature here that there's something I realize is starting to be a problem, and I wanted to remeasure that on all these pieces so far, I have the ability to do that. I can define a new measurement. Let's just grab one of these calipers, for example, and say, I just want to know how thick this is. I'm going to use feet, set up a new caliper measurement that measured on this one, but I have 7 other pieces I want to go add that to. I can do what Polyworks calls propagation and send that measurement back through time to all those other pieces that I have scan data on. As long as they have scan data in the area that's sufficient for that one feature to get scanned, it's going to extract it from them. So if this is going to do that, it's crunching through, just open each one of those pieces up, making that measurement. It's going to make that change to the report also. So really powerful, especially this will work with as many pieces as you have it, and it'll take a little longer if you have 100+ pieces, but a super powerful feature of scanning versus other kinds of measurement. Once that's finished too, we can also look at some statistics. If you wanted to, you've got a really critical dimension that's trending, you're starting to have issues with it, you want to watch the trends on that one feature, you can pull up a chart and see exactly what that's been doing and track how steady it is. Maybe a tool is wearing out and that hole is getting too big or too small, and you can find that out really quickly. Almost done propagating here. And then I'll pull that up. Cool. So for example, let's grab that caliper just to see that measured on all of those parts. Hit this SPC button. So SPC, if I didn't say it already, statistical process control is what that stands for. So just statistics on your manufacturing process. So each of these features that I have on the screen will pop up a little chart that shows me a measurement at each individual value. I've got each individual piece here. We've got some statistics that we can look at. I can open this menu. This is the full list of every statistic that Polyworks can give you about this part here. And so again, this is showing me 8 pieces worth, but it can be as many as you have pieces for in here. It's got a bunch of tools for filtering out. You only want the last few, depending on what kind of problem you're trying to solve. Yeah, again, really powerful. I know recently I've been asked to if this works for like measurement system analysis. Instead of doing multiple parts, you want to do the same part multiple times and try to gauge the measurement, the MSA value of a measurement system. That's something that Polyworks is fully capable of also. In fact, they've got a whole workflow for doing that here, for picking some features to base an analysis on, setting up an Excel template that can, you pull all those measurements into, and it does all the math for you and figures out your reliability of your measurement system over multiple pieces, multiple operators, multiple measurement modes, gauge R&R, that sort of thing. Do all that in here. Cool. We'll keep Polyworks up in case there's any questions or anything come up with that, but we'll move to the hood back there. So we messed with a lot of the laser modes. We kind of went through everything except for the infrared mode, so the ultra wide field of view one. So that one, it's infrared lasers instead of blue lasers. It's an extra large field of view, so you can use it, measure large areas with minimal targets really quickly. But it does limit your resolution to 1 millimeter. So that's something we'll do here in a second once I get Leap back open. We're also going to run through photogrammetry. So that's technically the 5th mode. It doesn't really involve lasers, but it's the 5th data capture mode. So that's why I have, in addition to my regular adhesive targets, I've got these magnetic coated targets applied to this part also. So photogrammetry is an alternative way of capturing your targets that maximizes your volumetric accuracy over areas larger than like this turntable, for example. aboard this table. It involves those coded targets and those scale bars. Those are all the stuff that you need to do this is included in the case. The scale bars are actually like the doors for the calibration board. And yeah, that's how that works. So we've got Leap Capture back open. This time, instead of starting with a marker scan, we are going to start by capturing those photos for photogrammetry. So just open a little secondary window inside of Leap Capture. And then buttons on here. There's some buttons on the back I've been using to like start and stop my scanning. There's a little trigger button here is what I'm about to use to capture these photos. Usually takes a handful of photos before the initial registration happens. So I guess before I mention that, I should say what it's doing. I'm taking photos. It's using those coded targets, those little square targets and those scale bars to determine exactly where the photo was taken from. So this data you're seeing on the screen, the little colored dots are each of the coded targets. Those two yellow lines, they're yellow and they'll turn green once I capture them better, are those scale bars. And then each of those little like pale blue squares are photos that I've taken. So I can manipulate this view around a little bit and kind of see the scene from that angle. As I take more photos, more of those little squares will pop up. I probably need to get 40 or 50 for this one, and I can go really fast once I'm started. And you'll notice everything's turning green. It's good to hit it from a few different angles. And notice how much further away I can be than if I was capturing targets on their own. Once everything I need is green, I can just ask software to finish crunching all that for me. And it's not just captured those coded targets, that's all it's showing me. But then you'll see once it's finished crunching, all these other targets pop up. Those are the locations of all of those little individual adhesive targets also. So we'll send that back to Leap Capture. I'll take these guys off of here. The little magnets. You don't have to do this, but I find it's usually best. Missed one. Cool. So all those targets got transferred back over to Leap Capture so we can start collecting some data. So you won't see the lasers on camera. You'll see this green rectangle that's kind of showing me, because I can't see the lasers either with my eyes, showing me where that field of view is roughly. And you can see the lasers on the screen, the red laser pattern there. So you can see how large that area is. Really quickly, just a couple passes, I'll fill up everything on this door. Again, once I have everything I want, I can stop. Leap Capture does some filtering. We can get rid of infrared mode is inherently a little bit noisier, as you can see, but that's really easy to take care of. Disconnecting components takes care of all of that stuff. Again, still a point cloud. If we zoom in, you can see those individual points. And we'll mesh that and make it a surface. save that guy off real quick, and then got another couple little parts to look at here on the turntable. So we've explored the kind of the medium range or medium sized things like this small casting. We did something big with that hood, and you can kind of imagine how this would make it really easy scanning even larger stuff to full like vehicles and boats when you just need decent resolution on the major surfaces and nothing super tiny and detailed. That infrared mode will let you get through that really quickly. We've also got some tools that are really awesome for higher resolutions. So if you do want the tiny details on something, I've got this little cylinder head or piston head that's got some fine little engravings on top. We'll scan that and take a look at the level of detail we're able to capture. So I mentioned the target capture process. That's what that looks like really quick. Just a few seconds of making sure the scanner can see the targets that you want to capture. Let's open another clipping plane. And start scanning. So I still have access to the individual lasers, or sorry, the different laser modes. So I do not have infrared mode in this finer resolution, but we do have laser crosses. I also have hyperfine, which is what I'll stick with for most of this. Might seem like it's taken me a little bit more time to fill in the same areas, and it's because I reduced the resolution, or sorry, reduce the distance between the points by a factor of 8, which means it's got to capture 64 times the points to be able to fill the same area. So that's why I'm having to move a little bit slower, but I'm collecting just as much data as I was before. It's all just concentrated in a smaller zone. These other buttons on the back of the scanner I can use to zoom in, see what I'm capturing a little bit better. I can even adjust my exposure from here. I don't have any reason to. The sides of this are a little shiny, and if they're not picking up super well, that's probably all I need to do to make that happen. But everything looks like it's coming in just fine. So we're not at maximum resolution. This is pretty close, but I can go technically a little higher than this, but it's resolving all these little inscribed areas here, little embossments very well. That's even, I think that's just ink on there. It's not actually picking the ink thickness up. There's a, but you can tell that that's there. These are actually, included in the casting. They're actually embossed on the part. Let's see here. I mentioned shiny. I've got a part here that kind of shows you how that works. A lot of, especially in the past optical scanners, you've had to do some sort of spray or some sort of coating to get really shiny or transparent stuff to show up. But blue lasers. So I've got this almost mirror chrome little exhaust tip. Blue lasers are really good at handling that. I will probably need to bump my exposure up just a little bit, but that's all I should need to do to make sure this gets captured. You notice it's like I've got to get a little bit more perpendicular to the surface before it starts picking up. That's kind of typical of a harder to scan surface, but So it might take just a little bit longer, but it'll still come in without applying anything to it. I even go to a single laser. That'll help me get all the way down inside of here. Start with the crosses and see how deep we can get. I'm getting pretty much all the way down there on the inside. Just takes a little bit of finding the right exposure and the right angle. I'm able to fill all of that in. Anybody has anything, I've got a whole big shelf of parts. If there's any sort of thing somebody'd like to see, feel free to shoot a question to the Q&A and I'll see it pop up and we can take a look at something if you'd like. How big of a part can you scan? I have a question. Great question. Basically, as large as you have targets for. So the ultra or the extra large field of view infrared mode can make that even easier. I've personally scanned, I'd say, some pretty large stuff with this. It's like 30, 40-foot boat molds. It took a lot of targets, but as long as you can apply those targets to that object, you can scan them like with target acquisition mode very quickly. You can scan them using photogrammetry with a few extra steps and maximum volumetric accuracy. But yeah, you can scan really large stuff with this guy. Let's see here. Grab something that's off the shelf here to look at. Do you have to have targets on a part to scan? No. Great question. So we did have some on the transmission, a little bell housing that I had here. And I've got a little gear here that has a few on it, but I'll take them off real quick. But so they add, in the case of the bell housing, they added a little bonus, easier alignment step. I could have definitely aligned without them. I could use common geometry from one scan to the other, pick the 3 common points between the two, and then as long as they have enough overlap, they'll align like that. And but no, you do not have to have targets on the part. So in this case, I've got just the ones on the turntable. We'll set this little gear on there and just use the targets on the table, as long as the part does stay still. If something's moves around, you have to make sure it's not doing that. So if it's not weighted enough to make sure it's not moving around, you can sticky tack or fixture it down somehow. I've got a question about how do we calibrate? I can show you that. There's just a little calibration board. I'll pull that over here as soon as we're done with this guy, and I'll show you that process. There's a little gear scan. Mesh that. I'll grab my little calibration board. So here's the board that's usually got those two scale bars on it as little doors, but this is all you need. Take this and set it down. It can be on a table, but I like to have it a little lower. So I like to usually set it in a chair like this. See me. There we go. And there's a calibration button up here. Just grab that. You grab the scanner, point it at the board, and once you have it in the right area, it'll show you these two images. So I've got the gray one is my actual scanner position. The other one is my target position. I've also got the little crosshair and circle to show me. The circle shows me how far away I am. Crosshair shows me what I'm pointing at. Just got to line that stuff up. And until the target turns green, hold it there for just a second. And then that's one step complete. Then there's just 14 steps I got to go through really quickly. The first 10 are all in a straight line. So all I've got to do is hold the scanner steady, move it straight up away from the board. And then the last 4 are just the 4 different directions. Right, left, up and down. As soon as I finish these last 2, it'll think for just a second and pop up an accuracy value. It'll show up in millimeters. So we'll see 3 decimal places. That's 9 and change microns that it's showing me. And once that pops up, everything's saved. So calibration stored on the computer, and I'm good to go. Let's see if we meshed that guy. And save that off. Figure I can show you. This scanner would be great for reverse engineering. Also, we've kind of looked at inspection so far, but I can show you a real quick bit of like 1 or 2 steps might take towards turning this into a CAD model. So to do that, we'd be looking at this. Geomagic Design X is one of our reverse engineering offerings. It's a fully fledged CAD software. So it's capable of doing any kind of solid or surface modeling you'd expect any of the big CAD names like SolidWorks or Inventor or CATIA, Creo to be able to do. You might recognize some of these commands if you're familiar with those: extrude, revolve, sketch, circle, line, and such. But on top of those tools, it's got a whole suite of tools specifically meant for taking scans. So like this STL mesh file that we just dropped in, I just saved that out of Leap Capture and brought it in here. And using these as really high accuracy templates for creating 3D models from. So common steps to do that involve like making some selections on the surface. A lot of tools that interact with meshes only have like a lasso tool like this or like a paintbrush, which can be a little bit slow at selecting certain things, but you can grab Smart Select inside of Design X and use it to really quickly grab mechanical faces. What it's really doing in the background is selecting whatever face I click on, whatever triangle face, and flooding outwards, and it's moving until it sees a certain amount of angle change. And if I hold my mouse down and drag upwards, it's just changing that threshold. So I can really quickly dial in the sensitivity so it's able to grab mechanical faces super fast. And I can grab those selections. I can fit a plane to that, for example. That's probably like one of the datums I'd want to use to make a coordinate system for this scan. I can grab like the cylinder on the inside of this. And then what I'm doing to save them is save them as regions. So these are just little predetermined areas of mesh that I can then click on with one click to select them again later. I can even hover over, it might be too small to read, but my cursor says plane. It's identified that as an area that I can fit a plane to within a reasonable accuracy. That's a cylinder. So all these are ready to use for alignment. I can just jump into my alignment tool and say, I want my origin to be where that cylinder axis intersects that plane. I want my up direction to be that. And if I wanted to, I don't have a reference for that last direction because it's just rotational, but I could eyeball that one if I want, or I could grab a third reference, but I can just eyeball that keyway to the top there. So now say I want to just create a major part of this. We can do instead of a regular sketch, we'll do a mesh sketch, which starts with this first extra step of just grabbing a cross section to work with. So it creates these pink lines. These aren't fully ready to go sketch entities yet. These are just lines options that a template that I can use to fit those two. So like tracing paper. And now I can grab my circle tool, and instead of having to click and drag and draw my circle, I can just single click and select a circle and fit it to any one of these areas here. I've even got an auto sketch button that'll do this really quickly to a lot of different areas. I can have it do everything. In this case, I'm going to still manually select a few things that I want it to do. Make all of those for me. I want to do a rectangle to this area here. I can do that. We'll do one more circle on the outside there to define like the outside of this. So I can always I place this circle at the origin because I know I'd want that origin to be there. And then I can just click. If I know I want to actually fit it myself, I can still snap it to things instead of having it best fit to, all of that outside area. So then we can just extrude this guy. So you can, now that I'm starting to actually make a solid model, I'm doing that right on top of my scan. I can do that. I really just start to eyeball thicknesses here. It looks like this thing's about an inch thick. I just started my plane kind of in the middle of it. But once we've made that, we'll see it pop up on top of the scan. And now I can see, if I wanted to see a color map of how well what I've modeled fits, I can do that. So the only thing that's perfect is where the tips of those teeth are and the top of this. Everything else I need to do something else too, but it's showing me that exactly. So I can see that red is a little bit more like 1/4 of an inch. Anything green is showing me it's within a certain threshold with 4 thousandths. Sounds pretty reasonable for a gear like this. Let's call it 5. So now anything up to 1/4 inch to that darkest red color, I can even hover over and see exactly how far off I am. It's like a little shy of 1/4 inch there. This green is probably within, really close to a thou. And so that really, that instant feedback that you're getting there is really powerful, because oftentimes you'll want to change, if this didn't look good, or if I wanted to change my modeling strategy, I have the power to do that now, instead of if I modeled a bunch of stuff, send it over to my CAD program, and then had to figure that out later. I'd have to kind of restart over. But here I'm able to just back up and say that circle was a little bit too big. I can see that in the color map. There's no green on the outside now. I can immediately just jump back into that sketch and adjust it. Oh, that scooted everything. I just want to change the diameter of that circle, snap it to pink, and get that instant feedback. Then once you have some faces, you usually don't have to make any more planes. You just grab a face, do a new mesh sketch, scooch it around a little bit. Usually don't want exactly where a face is. You want to scoot it around a little. So if I want to make this like inside circle here, we'll do that. Nope. I think I clicked out of Sinex. Oops. I get keyboard shortcut happy sometimes. I think I might have closed my window. Looks like we're almost out of time here. I'll do just for funsies, we'll do that super, super fast without a whole lot of talking. To kind of show you a little of somebody using this to do some reverse engineering. There's not usually as much talking. It's usually just doing and you can go really quickly and get some really cool CAD models really fast. So this is that step I was trying to do, that inside circle. We just want to go cut that out a little bit. You can see how I just was thinking that'd be really far off. I kind of just guessed, but that turned out to be super, super close. So yeah, you can kind of keep applying those tools over and over and make fully fledged CAD models. Once you're done making those models, you can send them over to, you can save them off as a step file. You can send them over to SolidWorks or a few different CAD softwares automatically. What I'm doing here is I'm making this fillet, and it's actually automatically deciding what that fillet radius should be, or I can punch it in myself and use that heat map to decide. But yeah, again, you can save off a step file. You can send it over to any of these SolidWorks, Creo, Inventor, NX, or AutoCAD. Have it send the full featured tree over, so you'll have this model and everything you need to make any edits to it, any dimensions that you defined while you're going, anything like that. Yeah, go. Looks like we're approaching the end of the hour here. So if anybody has any last questions, feel free to drop them in the chat. Otherwise, we'll wrap it up. Cool. Thanks again for joining me. Yeah, again, this was the Digitized Designs Scanner Spotlight series, this time focused on the FARO Leap super versatile metrology grade laser scanner, good for inspection, reverse engineering, all kinds of stuff. If you'd like to learn more about it, you want to see a demonstration, feel free to get in touch with us at our website, digitizeddesigns.com, and we'd be happy to talk to you and help you pair you up with the scanner that you might need. Cool. Everybody have a great day. Thanks.